Welcome everybody to this edition of the Power Hour. Now we've been talking engine management. Last month you saw us talk about cool oil and the benefits of oil coolers. Today we're going to go one step even cooler as the weather's getting warmer. We're going to talk about air conditioning. More specifically about doing the job right and how do you verify that you actually did the job right. There's some verification steps we need to make here, and so I'm going to share some of that with you here today. And we'll actually roll back the clock maybe 20 years ago and talk about a topic, temp testing. All right, so let's jump over to the bench and get rolling. When it comes to verification or making sure the system's working right, there's a couple things we're going to do here. We're going to obviously look at pressures. So on the car we've got in the bay here today, we've already gone ahead and replaced the compressor. We've used the AC service kit, which comes with the expansion device, the required oil, all the components necessary to go along with this compressor, except for maybe the condenser. I'm going to share a little bit later in the presentation here why it's always a good idea to replace the condenser at the same time as the compressor. So this installation kit or the service kit came with the compressor and really, again, gives us everything we need to do the job properly. So we're going to monitor pressures and we're going to monitor temperatures. And so a lot of technicians I see today, when they're checking temperatures, they're using one of these temp guns. Well, that's a very inaccurate way of doing it. They will argue to the death and go, well, see, there's a red laser beam there. That's where it's measuring. That's where it shows you to point at. But in all reality, it's a broadcast average of the temperatures in there. So if an exhaust manifold is nearby, it's going to be reading off that as well. So I'm going to recommend always to use my friends here from Fluke. They've got a great temperature probe. Sometimes you're gonna maybe even duct tape it to a dowel, give you a further reach on it. But when you actually touch something, it's gonna give you the reading off what you're touching, not this random average throughout the base there. Another great tool is the temp select tool here. And as we talk about temperature testing, we're gonna measure the inlet and outlet of the condenser, of the evaporator, et cetera, throughout the system here. This is a great tool for that. It's got these probes you can clamp on there and it will show you a reading of what you're reading on each probe. And it will also tell you the delta, so you don't have to do a whole lot of that math there in between. But one of the caveats here is on today's vehicles, there's a lot of variables. And back in the day, temp testing was an exact science. On today's vehicles, we have variable displacement compressors, electric compressors, and a lot of other stuff going on. And so we're going to be using this ECV tool also if we're working on one of those vehicles to ramp up the compressor. Make sure it's at 100% max command, because if it's only pumping at 50% based on the PCM command, it's going to have an effect on our temperature readings there. So there's some variables on that. That being said, let's kind of jump in here. So this is nothing new, but some of the keys to a successful compressor replacement are that every inch of the refrigerant path should be new or flushed. So in this case, I've really replaced absolutely everything on the vehicle except for the evaporator core. We replaced the lines, they've got mufflers on them. We don't want any debris trapped in those mufflers, and so we got to be careful with that. We've replaced the condenser. So really everything in the system's been replaced except for the evaporator core. It wasn't leaking. It's a lot of labor to get behind the dash on those. So in this case, every inch of the refrigerant path has been new or flushed. We need to be very careful as we recharge the thing. Make sure that we're using the exact type of oil. Again, by using the service kit, it came with the correct oil, the correct type of oil and the correct viscosity of oil. But then we had to look in service information and make sure we use the correct amount of oil. And then airflow is key to successful AC job. Not only airflow across the evaporator core, so we had to make sure the blower motor and resistor was working properly, but more importantly, airflow across the condenser. The cooling fans on this vehicle are both of them working properly here. High speed, medium speed, low speed, etc. So we've got good airflow helping to remove the heat from the AC system here. So as mentioned, I had to roll the clock back here a little bit, dig up some material on temperature testing. And as you can see by some of the images here, look at this Ford Ranger. I mean, what's that, late 90s? And so this is a big topic in our training material back in the days. It's still got some validity. Again, there's variables in today's modern vehicles. I still think it's very important for technicians to comprehend this information to know how the system is working. So to do the temperature test, we're gonna have the vehicle at idle, up to operating temperature, so make sure the thermostat's open at least once. All the doors open, AC on max cold, recirc mode, crank that blower speed up to high. And again, we want it really outside to get the best results. I'm here in Texas today, it's a sunny day. That sunlight coming in is where a lot of our heat load actually comes from. So we want to really stress test the system, make sure it's working properly. And now we're going to measure the temperature differences here. And so we're going to go to the condenser, measure in and out temperature. Again, using this temp select tool I've got on the cart here, really makes it super easy on that. We're going to measure the evaporator in and outlet temperatures. That might be a little bit different on a TXV vehicle. It might be difficult to access some of that. And then we're going to measure the ambient air and compare it to the duct air. And if you go to 4s.com and you look up training resources, you're going to find a worksheet there that you can print off and fill in the blanks for entering in some of your information here. So really what we're going to do here is we're going to put the max stress on this AC system. Yes, we can all cheat the system. I've done it myself 100 times, where you rev up the engine a little bit, it means the compressor's turning faster, we're getting better performance. But on a hot Arizona day, Florida day, whatever, and the customer's sitting at idle, or they just start the car up, we need to make sure it's performing under the most strenuous conditions. Again, this is an older portion of a presentation, as you can tell by the penny loafers and the guy working on a 1994 Jeep Cherokee here. But these are the specs that we're looking for regardless of the system we're working on. So across the condenser, from the inlet to outlet, we want to see between a 20 and 50 degree temperature drop there. Now in the evaporator core, we want to see ideally no temperature drop, zero change, maximum plus or minus 5 degrees. And then the duct temperature, under these conditions here, from ambient temperature to duct temperature, we want to see at least 30 degree temperature change. Now, of course, when we close the doors, we put on recirc mode, we raise the engine RPMs here, we're going to obviously see a much greater temperature change. But under these conditions, we're looking for at least a 30 degree change. So a couple conditions here we want to think of. We're kind of looking here to make sure that it's a warm day. If it's too cold, obviously we might want to turn the heater on in the shop, or do a couple different things there. But again, this is from our older presentation. Some things to keep into consideration are when you're using this temperature probe and we're placing it on the vehicle, it makes a significant difference if it's a painted surface or a bare metal surface. So sometimes you might have to take your little gasket cleaning device and clean some of the paint off to make sure we're measuring on bare metal to get a good, accurate reading on the system there. Some of these have limited contact area. As I mentioned, if it's got a TXV, it's very difficult to access and differentiate between the inlet and outlet of the evaporator core. And some of these GM trucks where the Orifice tube is actually inserted into the tip of the evaporator core, it's very difficult to get beyond that. We don't want to open up the case, etc. So there's always been some type of limitations. But now as we move into newer vehicles, we've got additional limitations here, or extenuating circumstances that's going to change our outcome on this. So as mentioned, if you've got a vehicle with electronic variable displacement compressor, the PCM or the HVAC controller is going to be ramping the command of that compressor up or down. And so sometimes it's going to be full output, sometimes it'll be a minimal output. That's where it's benefit again to use this ECV tool, and you can drive it to max output on the compressor. Make sure that we get rid of that variable in the equation. Because if this compressor is only pumping at 20%, our results are going to be significantly different. Now we've got modern vehicles, hybrids, electric vehicles that have electric compressors. Well, those things are infinitely variable, and they will be ramped up and down at different times. So a lot of times you're going to have to go into service mode. If you got a Tesla, you can go into the service mode other vehicles, you're going to take a scan tool and put it into AC service mode to ensure that we've got consistent output from that. But yes, your results are going to vary here. And then we've got today's vehicles with electronic TXVs, thermal expansion valves. And so the PCM or the HVAC controller is adjusting the amount of Freon going into the evaporator core based on the demand there. And so again, that's going to have a significant effect on our temperature testing here. So again, this was a pretty exact science on older vehicles. I know a lot of dedicated true air conditioning shops in the South, they could hang their hats on it. And still today, they've done enough of them. They've got enough experience. But I wanted to share it with you here today because there is still some value there. I think when we understand the full concept of the AC system, it's beneficial for us all to understand just that concept there. You might not use it every day, but it's still good information to know. So let's kind of review basic air conditioning components, put them all together. Let's go through a repair job and kind of wrap up the verification process. So when it comes to AC system, on the left-hand side there, we've got our pressure changers. We've got our compressor, which is going to build pressure. We've got our expansion device, whether it's a TXV or an Orifice tube, which is going to drop the pressure and help change the state there. Now we've got our kind of state changers, if you will. We've got the condenser, which will take the refrigerant from gas, turn it back into a liquid. It condenses, just as the name implies. Then we've got the evaporator core. Once again, as the name implies, it's going to evaporate. So we're going from a liquid to a gas in the evaporator core. That's where we're going to grab onto the heat and send it back to the condenser to remove the heat from the vehicle. Then we've got our carriers or filters here, being the hose assembly and the receiver dryer or accumulator. So as we look at a TXV system, we've got kind of the computer in the middle there. Today's systems are very much computer controlled again, and that's going to control the compressor. It's going to have a temp sensor, might even be controlling the TXV. So the compressor will compress, build pressure of the gas state refrigerant, go through to the condenser, and now it's going to condense, turn into a liquid. At the condenser, the cooling fans are going to remove the heat from the AC system. It's going to send that liquid refrigerant through the receiver dryer all the way up to the TXV valve. That's going to drop that pressure. And so as it drops the pressure, now it's going to pool in the evaporator core. As the warm air from the cabin of the vehicle is drawn across it, it's going to cause it to evaporate, and it's going to remove that heat from the vehicle. And then it's going to start the system all over again. So think about these AC systems as your home refrigerator. You can't cool your house by opening the refrigerator door, right? It's removing the heat from the inside of it. And if you feel around the back side of the refrigerator or underneath, you're going to feel that heat being released. That's really the same thing that's happening on an automotive system. Now, as we look at the kind of older technology here, an Orifice tube system, again, we've got the compressor building pressure. It's going to pump the gas refrigerant to the condenser, where it will condense, turn it back into a liquid, remove the heat from the vehicle. And now that refrigerant's going to go through to the Orifice tube. Orifice tube is a small metered opening, and it's going to drop across there. The pressure will drop. It's going to deposit it into the evaporator core where it will pool. It's now going to evaporate, remove the heat from the cabin of the vehicle, go back through the accumulator before it goes back to the compressor. So a quick run through of the two basic AC systems there. Now, as I mentioned earlier, replacing the AC condenser is almost a must on today's modern vehicles. Around 2001, manufacturers made a significant change in the design of AC condensers, significantly improving the efficiency of them, but we have now smaller and more passages inside of them. And so it's very difficult to actually flush these. Now, I've argued with many a technician of, oh, I flush those things all the time. I blow the flush in and it comes out the other side. The real question is, how much of that condenser are you actually flushing? If the bottom half of it's completely plugged up, are you actually getting all the debris out of it? Or is the flush material just going through those open passages and simply bypassing the rest of them? We need the complete surface area of that condenser to make sure that the AC system is working properly. And so add that on. as you're getting into AC selling season, it's a good thing to remember, replace the condenser after a compressor. If we go back to those earlier images, right, the refrigerant leaves the compressor and goes directly into the condenser. So if we've got a compressor that went bad, now all the debris has gone directly into that condenser, and it's almost impossible to thoroughly flush that thing. So we need to replace it. So let's take a look at a recent case study. I actually did this on this truck here. I know the history of it. And so the concern is no AC. It was charged a couple months ago. Last year, the evaporator core and the fan clutch were replaced. Now, it's very important to note that the fan clutch had been replaced already. On these Dodge Rams with a Cummins engine, the electroviscous cooling fan is going to have a huge impact on the AC system performance and ultimately on the longevity of the AC compressor on these particular vehicles. And so it's a good practice to scan the vehicle anytime we're working on it. With these Dodge Rams, it's not going to turn the check engine light on, but it will actually set a trouble code in the ECM if that cooling fan is faulty. And so this had all been done a year ago. We just want to make sure that it's not happening again. So we've really verified at this point, or here we look at the scan data, we can see that that cooling fan is operating properly. Now that's an important note here. A lot of times people will say, well, the car is not overheating, the fans must be working fine. Well, we've got case study and plenty of research and illustrations we've done here at our vehicle testing facility. On the other side of the wall here, I've actually got our tech line, and that's something that comes up a lot of times. The car's not overheating, the fan must be working properly. No, that fan needs to work extra hard to remove the heat from the condenser or from the AC system. And so just because the vehicle's not overheating doesn't always mean that fan is working properly. So please do your customer a favor and protect the longevity of the job. Make sure that cooling fan is working properly. We did on this one. So now we're going to go through, we're going to use the sniffer, try and determine if there is any leaks. The condenser, really no leaks there. We didn't come up with any really good leaks or solid conclusive evidence. I've had scenarios where it very quickly found the leak here. And we're actually using a trace gas. And so that reminds me, there's a quick little tip here I want to share with everybody. And I learned this the hard way from several shops. Shops that are using the hydrogen gas or a specific gas to detect AC leaks. You see how they've got the balloon over the outlet here? That's to help ensure that nothing's leaking past that valve. There's nothing worse than somebody not closing the valve properly, and you think you've got a tank full of gas to use here, and then all of a sudden go, oops, it all leaked out. Or in many scenarios here, the tracer gas is going to be lighter and smaller particles than the rest of the gas that's in that tank. And so that's where it's important to make sure you capture it all here too. So even in this scenario here, I'm going to crack the valve open a little bit, put some gas in that balloon, and then use my sniffer on that balloon to determine if it's actually working properly and make sure that we actually are getting accurate gas on that point. So on this particular truck, we went back to our good old friend, the UV dye and the lights here. And so we made sure that the compressor is the actual source of our AC leak. So, raise the question here for the audience. We know that we've got a problem here and we've got a faulty compressor. What are we going to replace? Well, a lot of technicians will say, hey, it's just a leaky compressor. It's leaking from one of the seals. I'm just going to replace the compressor. That all sounds great, but in reality, we need to replace all these additional components with it. Why is that leaking just out of the seals? Well, maybe previously those seals were damaged when the cooling fan wasn't working properly. The head pressure got too high. But also, let's say we've got a restricted or we've got debris in the condenser or the orifice tube, etc. We need to replace all this stuff anytime we were replacing a compressor. So in this case, we bit the bullet, or a condenser, or the complete AC service kit here. So you can see it came with the accumulator, it came with the lines, because it had a trapped orifice tube in it. It came with seals and gaskets, came with the correct oil. Even came with a note here, a warning on this particular application to check the fan clutch there, which obviously we had already done. So you see it's got the exact fit accumulator. We got the oil there. We need to know where to put the oil. So we look in service information here, and it tells us how much oil we need in the entire system. And it tells us where to put the oil. So we're gonna put 2 ounces in the accumulator, 1 ounce in the condenser, 2 ounces in the evaporator, and then we're gonna match the rest of it into the compressor there. So in order to get the line that's got the Orifice tube in it apart, we gotta pull out the right front or the passenger side battery. Remember, it's a diesel, so it's got dual batteries here. So we had to pull that, get a little bit of inner fender access there to get towards this. And now I went one step further here. Just out of curiosity, I cut that line apart to look at the Orifice tube. And I was amazed, and hopefully you're catching the point here too. Look at the amount of debris in there. This is a system that was really working fine other than it was leaking from the compressor. So it really helps illustrate the importance of do the entire job. Just because we got a leaky seal in the compressor doesn't mean the rest of the system is okay. If I would have put the new compressor on this, I would have been having performance issues, probably wasn't gonna be cooling properly. I probably would have seen a repeat compressor failure. And that's the type of phone calls we get on our line all the time. And so again, I can't stress enough the importance of doing the entire job properly. So again, I'll confess here to you all, feel like we're friends at this point. I've flushed systems with this type of tool for many, many years. You put the flush in the canister, you pressurize it, you press the button, and you send the flush material out, you run some shop air through it, and you call it good. Well, since I've started working here 15 years ago, I've come for a completely new appreciation of how to properly flush a device. And that's where I appreciate this tool here. You'll notice it's got the spring lock clamp. And so at this point, we can hook the tool to it, it stays on it, and then I can walk away. And so we want to run at least 15 minutes of shop air through this to help get all the debris, all of the flush material out of that evaporator core. So yes, there is such thing as a faulty flush. If we're going to do it, let's do it properly, remove all the flush material from the system. So we've put the appropriate oil in the condenser. We've installed the new condenser on the truck. This is a little tip also I want to share. We add the oil to the compressor, and I don't want to drop it. We want to very carefully set it on the nose here. And so what that's going to do, it's going to get a little bit of oil on the front shaft seal. We want to make sure that's good and lubricated. If it's a dry seal, well, it could cause a leak at some point or damage that seal. So we've now lubricated that front seal. We've installed the compressor, and now I'm going to rotate it by hand here several times to make sure that we've gotten the oil to the right chambers. I don't want to just start this truck up. Remember, it's a diesel. It's got a lot of torque. It's got a high torque starter. And if the compressor is turned on at this point, we could hydrolock it, we could damage it. So by rotating at least 10 times by hand before actually starting the truck, I'm going to make sure that the oil is in the right areas of the compressor that it needs to be. So now we're going to vacuum this thing down for at least 45 minutes. Once it's done, we make sure that it's complete. It's been able to hold the vacuum there. And we're going to put in the full charge as recommended in service information. Yes, we can go by the sticker on the vehicle, but what if somebody's changed the front clip on the vehicle? I've seen a lot of times where somebody's got a different hood or something. And just because you did 3 of these earlier in the week, don't go by memory. Always look up and make sure we're putting the correct amount of refrigerant on the vehicle. Now we've sealed the system here. It came with these seals. And so I can put a tag on there, understanding who touched it last, and then make sure it's sealed. This is a nice little tip because how many times have you inspected, a customer comes back week after week after week and goes, it's leaking. I don't know, it's not working anymore. What if their uncle or neighbor or somebody was pulling refrigerant out of it or undercharging it or overcharging it? by actually sealing the system up here. Next time it comes in, if it's still got that locked cap on it, you understand you were the last person to actually work on it. And then we want to make sure that it's working properly. So here we are on this particular day. It was 90% humidity, 87 degrees outside, and we can see we're well below 40 degrees duct temp. So we've done a great job at this point actually fixing the truck properly. So to reiterate here, I want to remind you that the keys to a successful compressor replacement are that every inch of the refrigerant path should be new or flush. The system should be charged with the exact amount of refrigerant. We need to make sure we're using the correct type, viscosity, and amount of oil. So again, if you're replacing the compressor, these service kits or installation kits come in so handy. It really takes the guesswork out of what type of oil do I need, what accumulator or what receiver dryer or what expansion device do I need. These are paired together, and it really helps take the guesswork out of it. So let's kind of conclude here. One of the things we need to do after any job is verify that the pressures are acceptable when we're done with it. Make sure that the cooling fans work on all speeds and that the duct temperature is acceptable. And keep in mind, we've got variations here, the variable displacement compressor. There's other things that can be changed. One additional little tip, and I've been hiding this here, maybe saving it for last, is the use of the sight glass tool. This is so cool, and I've seen a lot more and more of it more recently, is you can hook this onto the high side and the low side. And so if the compressor is actually working before you start the job, you can run it through here, and it's a sight glass, so you can actually see the refrigerant going through. If there's debris, there's a filter here, and you can actually capture this. If your customer's in the waiting room, it's a great tool, or even you take a picture. If you're using a digital vehicle inspection system, take a picture of it, and you can show that picture to your customer of what's actually floating around inside of the refrigerant system on their vehicle. It's a fantastic selling tool, adds that additional visual piece. But in the case too, if we're done with the job, it's not a bad idea to actually run it through here also, just to make sure the system is clean, there's no more debris. If there is debris, you might need to take it down again and actually clean it one more time. So one additional cool little tool here. So we finished this job here. So if Corey will go ahead and start the vehicle for me. We've done the job by the book here, I think. And so we've got the vehicle started, we've got the AC on max here. You can hear the compressor firing up. I can also hear the cooling fans working here. And so right now here at idle, we're climbing on the high side yet. We're about 200 PSI. We're about 35 on the low side. So we've got what I'll call a decent pressure split here. We should see it settle in here. If it's gonna go too high, now I'm gonna be concerned and start looking at my cooling fan operation again. Because if that cooling fan's not working properly, we're gonna continue to grow here. But we've kind of settled in here. And so again, my pressures at idle here are at what I consider to be a good range. Now let's go over to the vehicle and look at our duct temperature. And so as we're here, we've got great cool duct temperature coming out here. And so, I'm very confident here in this Texas weather, this customer's gonna be very satisfied with the performance on their particular vehicle. So, we've done what we could on this particular car. I feel like we verified that it's working properly. And so you can go ahead and shut it off here, Corey. And, so we didn't do the temperature drop test on this one. We could have, but again, everything else really indicates that the job is being done properly. And we didn't piece it together. We replaced the condenser, the compressor. We actually replaced the lines on this because it has some mufflers and we didn't want any debris caught in there. So really everything but the evaporator core has been replaced. So I'm very confident in the repairs on this particular job. So as we kind of wrap things up here, we've got a couple additional resources here. And So I'm always going to recommend that you go to some of our YouTube channels here. You can go to the Four Seasons YouTube channel and look at some stuff here. We've got additional tips. You can see just even some of the more recent ones. We put up our various actuator temps. So if you replace the temp door or the recirc door, or you replace the HVAC controller, there's a lot of recalibrations or calibrations that have to be done before calling that job good. So take a look at our Four Seasons channel there. As mentioned earlier, you can go to 4s.com and you can click on Technician Resources, find out additional information at that point there. So I've been kind of seeing some of the questions coming in here. Most of them are comments, good refresher on some of the temp drop stuff. One of them is, where can I buy some of these tools? Well, this one here, you can find your standard or your Four Seasons rep. I know a lot of them are selling these for a promotional item. If you're looking for that sight glass tool, if you're looking for like this Fluke temp probe, you can find this online almost anywhere, or a lot of your parts stores will be able to find that for you there too. It's great. I mean, I always support the people where I buy my parts, but a lot of this stuff, the place to look for is online. And so let your fingers do the walking there. So that's really it. We look forward to seeing you next month, but I really wish you all the best air conditioning season. Remember, air conditioning used to be an option. Today's vehicles, it's really a necessity, especially as we talk about hybrids and electric vehicles. If it's not cooling the high voltage components, quite often that vehicle is going to be shut down and disabled. And so it's really a necessity and a year-long thing. And again, on some of these newer vehicles, we talk about these in hours of operation versus miles driven. So once more, I appreciate you all coming out here, and we look forward to seeing you next month.